see how some of the humans are wearing traditional robes of some sort?
Oops. No, I wasn't just watching cat videos by myself. That's not what I was doing. That's just sad if that's what I do when I'm bored. But I'm not doing that, so it doesn't matter. Okay, welcome to lesson 10.1, tangent lines. This whole unit, this 10th unit, this final unit, we'll be talking a lot about circles. A lot, like really a lot. Right now, probably all you know about circles is that they're round and they have a diameter and a radius, right? A radius starts at the center, goes out to the circumference. A diameter goes from one end to the other, and it goes through the middle. We're going to be talking about different kinds of lines, though. We're moving on to new stuff, more advanced stuff, and I hope you're ready. So, first line we're going to be talking about, and there are many different that we're going to be talking about. The first one we're going to be talking about is a tangent line, okay? Let's bring this down for a second. A tangent line. Now, a tangent line is special because it touches a circle at only one point. All right, a tangent line touches a circle, so it doesn't go through it. It's just going right on the outside and touching at one little point, like a B right here. That would be the one point. So CD is a tangent line. Now, there's a few theorems we're going to learn about tangent lines. The first one is the tangent to a circle theorem. All right, this is your first theorem you need to know. The theorem is this: tangent lines, all right, are perpendicular. Remember what perpendicular means? Perpendicular means it creates a 90-degree angle. So if you want a little help there, let's just put 90 degrees to help us out. All right? Tangent lines are perpendicular to the radius of a circle. So if you have a radius and you have a tangent line and these guys are touching, guess what? They make a 90-degree angle, like right over here. That's 90 and that's 90. Okay? So in this case, if CD is tangent to circle A, all right, and remember, we name circles by its center. We name a circle by its center. So A is the center of this circle. That's how we're going to name it. Name a circle by its center. Then what do we know? Then we know that line CD is going to be perpendicular, that's what this symbol means, to AB. All right, AB is the radius, CD is the tangent, and they create a 90-degree angle. All right, so how's that going to help us solve some problems, right? How do we apply this tangent to a circle theorem? Well, let me show you. The first one we're going to do here is look at this question. BC is tangent to circle A. Okay, BC, which is our line right over here, is tangent to circle A. All right. Find the length of AC. All right, well, let's see how we can use this. Well, if you look here, A is the center, and so that means AB is our radius, right? What that must create is a 90-degree angle, right? Because a tangent is perpendicular to a radius of a circle. So it looks like that we've actually created ourselves a nice little right triangle over here, right? So if I want to find out what AC is, all I have to do is use the Pythagorean theorem, because you use the Pythagorean theorem to find the third side of a triangle. So that is just a squared plus b squared equals c squared. Well, the only hard part of this question then is figuring out which one's A, which one's B, and which one's C. And just to help you, don't automatically assume that anything's B or C. The best way to do it is just draw a line from the 90-degree angle, all right? And across the 90 degree is always your hypotenuse, okay? So that's going to be our C, because it's across. So C, we don't know, so we're just going to plug in now. A is 5, so 5 squared. B is 8. And C, we don't know. So we'll just solve this. 25 plus 64 equals C squared. 25 plus 64, let's see, that would be 89 equals C squared. And don't forget to take the square root at the end. All right, do a nice little square root. That cancels out your squared. And we find out that C is equal to 89. So since C is our hypotenuse, which is right here, we know our AC. All right, AC is equal to the square root of 89. Did I not put that? Did I not put that square root? Silly me. All right, cool. So AC is equal to 89. Thank you. The square root of 89. Thank you very much, Tangent Theorem. All right, here's another problem. Let's see how our tangent to a circle theorem could help us here. We know that GD, all right, and EF are tangent to circle F. All right, we're given that. And we know that the measure of angle F is 125 degrees. So I'm just going to write that in there. All right, 125 degrees. What is the measure of angle G? Just right over here. Well, let's see here. How can we solve this? Well, maybe because we just learned about the two tangent theorem, we might be able to use that. And I think we can. If we know that GD is tangent to this circle F, then we know that FD is a radius, right? This is a radius. And that this creates a 90-degree angle right here. Furthermore, we know that this is also a radius. And since GE is tangent, we could also put another 90-degree angle. Now follow me because this is about to be pretty cool. What we can create right here then is a quadrilateral or a four-sided figure. What can we do? We know three of the angles now. We know 90, 125, and 90. How do we find the missing angle? Well, we should remember is that in a four-sided figure, the sum of the angles is 360 degrees, right? So all the angles are going to be 360 degrees, right? Because it has four sides. If you forgot that, you could always use the sum of a polygon formula, which is n minus 2 times 180, whatever, that's another way to do it. And we're missing this angle x. So we know that these four angles should add up to equal 360. So we just set up our equation now. These four angles equal 360. We know two of the angles are 90 plus 125 plus x is equal to 360. Okay, let's combine our like terms on this side. We got 90, we got 90, we got 125, all like terms. We combine those guys together, and let's see, we got 180 plus 125, which is 305, plus x equals 360. We're going to subtract 305 from both sides, and we get x is equal to 55 degrees. All right, so we know angle G is equal to 55 degrees. 55 degrees. Now, just always remember this. This is a theorem you got to know. Tangent to a circle, the radius and the tangent create a 90-degree angle. And that will help you out a ton. Next theorem. The two tangent theorem. Okay, this is the two tangent theorem. If two tangent segments are drawn to a circle from the same point, so in this case we have C, and we have two tangents drawn from this point. We have CD, right? And we have CB. Oops. Those are our two tangents. Then we know that the two tangent lines are congruent. All right? So I would know that CD is congruent to CB. It's just asking us the same thing here. CD and CB are tangent to circle A, and they meet at point C. So I know CD is congruent to CB. That's the second theorem, you know, the two tangents theorem. I also call this the princess hat theorem. Princess hat. Why do I call it the princess hat theorem? Because it looks like a princess with a hat on. And look how happy she is. Beep. Look at that little princess hat. So the two tangents theorem or the princess hat theorem, whatever you prefer, just states that if two tangents meet at the same point, right, two tangents are drawn from the same point, then the two tangents are congruent to each other. So if this was 10, this is also 10. How are we going to use this? Well, if we know AB and BC are tangent to circle D, we want to state the congruent segments, and then we're going to find the value of x. Well, if these two, AB and BC, are both tangent to circle D, then we know that AB is congruent to CB, right? Because that's the two princess hat theorem. These two are congruent. Well, how are we going to solve for x? We should know by now when two things are congruent, we just set them equal to each other. So 4x minus 9 is equal to 15. We're going to add 9 to both sides to solve this nice little equation. And we get 4x is equal to 24. Divide both sides by 4. And follow me over here for a second, and we get x is equal to 6. Right? Because these are congruent, we just set them equal and solve for x. Another way we can use this is a little more complicated. Let's take a look here. We know that AC, AB, and BC are all tangent to circle G. All right? That's our circle, G's in the middle. State all the congruent segments and find the perimeter of triangle ABC. So how are we going to find all the congruent segments? Well, let me show you. If you look here, we actually have like 3 of these princess hats. Our first one would be right here, EB and BF, right? These are all both tangents drawn from a common point. So we would say that EB is congruent to BF. EB is congruent to BF. So this would also be 4. We also know that we have another princess hat right here, DC and DF. Look how pretty that one is. So we know DC is congruent to FC. So DC is congruent to FC. And so if this is 7, this is also 7. And finally, we know that we have another princess hat over here, AD and AE. So I know AD is congruent to AE. Is congruent to AE. All right, so if this is 6, this is 6. Well, now we can find the perimeter. How? Well, to find the perimeter of ABC, we know all the side lengths. We just do that by adding these two together. So our first side length over here is 10, right? 6 plus 4 is 10. Our second side length is 7 plus 4, so that's 11. And our third one is 7 plus 6, so that's 13. Add these guys up. 10 plus 11 plus 13, and we get, let's see, 20, 34. We did it! God, we're smart. Well done, us. Well done. All right, our final point of this is called drawing common tangent lines. All right? Why am I teaching this? I don't know. They put it on the Regents, but I don't see the value in it, but I'm going to teach it to you anyway, so you should know it. We're going to draw all common tangent lines on the circle shown below. And what does that mean? We're going to draw the tangents that are on both of these circles. The first one would be out here. So we have 2 circles that are not intersecting. The first tangent would be on the outside, okay? So if I drew a tangent on the outside of both of these circles, that is our first common tangent. It's tangent at our first circle over here and our second circle over here. See? Touches both of them at one point. Our next one would be on the other side, right? So we'll just draw another tangent line. So now we have 2 common tangents. Now, I want you to think about this for a second. There's actually 2 more that I can draw. And before I do it, let's see if you can do it yourself. Try to find the 2 other lines that are tangent to both these circles. Where else could you draw one? Would you draw it out here like this? Is this tangent to both circles? No. Could you draw it like this? No, because it goes through, it doesn't touch these circles at one point, it touches both these circles at 2 points. So how can I draw another tangent line? Let me show you if you haven't figured it out. You can draw it by going across. Ah, of course. Look at that. So now these are 2 more tangent lines. So, if you have 2 circles that don't intersect, how many tangents can you draw? Let's see, we got 1, 2, 3, and 4. There's 4 tangent lines you can draw when they don't intersect, right? On the outsides and that little crossy thing. So, when the circles are tangent to each other, meaning they touch each other at one point, we're going to figure out how many common tangent lines we can draw here. And this one's similar to the last one, where you can draw them on the outside. So let's draw our nice little outside ones. That's 1 pair. That's another pair. Now there's 1 more I could draw. Have you guys figured out where I could put that 1 more line? Would it be like this? No, because that's not tangent. It touches the circle at more than 1 point. Touch it to here, 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 and here. So that's not a tangent line. Could I go like this? No, not tangent again. Where would be that missing one? Well, if you thought of this, good for you. The third one would be actually right down the middle, right? Oh, this thing, look at that, it won't even go through the middle. Right down the middle would be our third and final tangent. right? Because it touches at one point here, so it goes down right the middle, so we have just a tangent line here. So how many tangents do we have here? We got 1, 2, and 3. So if two circles are tangent to each other, there's 3 common tangents you could draw. And for our last one, we have circles that overlap. How many tangents can I draw? Well, let's give this one a shot. Once again, you could draw those outside ones, right? We got our outside one over here. Yeah, it's doing that again. That's being annoying. We have another outside one. And before you say it, yes, I know these aren't perfect. You know, I got to adjust them a little bit. There we go. Ugh. Okay, so we have 2. And can I draw another one? I posed that question too. Is there another one that I could draw? Well, let's see. Can I put it down the middle like I did last time? No, because it hits at 2 points, right? It would here and here, so this is not a tangent. It can only touch the circles at 1 point. Truth of the matter is, those are the only 2 that you can draw. So if circles overlap with each other, there's only 2 common tangent lines that you can draw. Well, ain't that cool? All right, guys, that's the whole lesson. Remember, say to your mom you love her because she deserves it. And your dad. And your grandma. And your granddad. Do it.